Welcome to this demonstration of the ADePT Design Manager software. As the name suggests, Design Manager is a tool that facilitates a level of management, updating and reporting of a design program without having to rely on time-consuming and fragile spreadsheets. It's designed to be used primarily by the person with a project overview, such as a project or design manager. When we begin, we click on the Manager main menu and select Open. Now we browse to the AML file that was created from ADePT Design Builder. This file has been synchronized with Primavera P6 and a program has been produced as a result in exactly the same way that we did for Aster at the end of the second ADePT Builder video. I now click on Draft and this gives us the option to resynchronize the AML file in the existing program. As you can see, I'm selecting an existing project and browsing to the Primavera file. I now select Find Changes. This is a useful step if any changes have been made in the program after it has been issued as a live document and provides a good opportunity to ensure that both the program and the AML file reflect each other. As you can see, because we're coming straight from the program we developed last time, there are no changes to make to the project, so we can click Cancel and this brings up a dialog box asking us if we want to change any settings for our work plan. When we're talking about a work plan, we're really talking about two periods of time. The first, that we refer to as a focus period, is what we want the designers to report on the next time we meet. The second is the look-ahead interval and occurs following the focus period, and this gives us the ability to interrogate any problems that we foresee proactively. In this case, I'm going to assume that the project manager is going to update the program and reissue it every 2 weeks, so I'm going to leave the focus interval at 14 days. I'm also going to set the look-ahead interval to 14 days, which in total gives us a 1-month slice of the program that we're going to be looking at. If I click on Constraint Types, you'll notice that this comes pre-populated with common constraints that occur on other projects, from awaiting decisions to a change in design. You can also add or edit specific constraints for your project, as I'm doing now. I'm going to put in a constraint that we'll remember, such as awaiting survey information, and then close the Work Plan Settings window. Design Manager now synchronizes itself with the program and looks for those tasks that match the parameters we've just set. That is, tasks which are occurring in either the focus or the look-ahead periods. Once that's done, you can see that Design Manager has found a number of activities that match our settings and put them in the left-hand window referred to as the Task Finder, and the icons next to each activity indicate what action is associated with that activity. This image shows, for example, that some tasks are due to be started and finished in the focus period, indicated by a red arrow, while others which start in the focus period are only due to be completed later in the look-ahead or after, shown by a green arrow. Obviously, we'd expect different percentage completes reported on these activities at the end of the focus period, hence the different symbols. As you can see, there are a number of procurement activities that occur in our program as milestones, but I don't really want to monitor progress against those. So I'll deselect them and then add the remaining activities to our work plan by clicking the Add Selected button. On the right hand side of the screen, we now have our first draft work plan, a to-do list for the next 4 weeks if you like. We now make this available to the other members of the team by clicking Publish. At this point, the software asks for a login. The second demonstration video will continue from here and discuss what happens when a work plan is published online for the team to access. But for now, I'm going to click Cancel and publish it offline. To do this, I'll open the Manager menu, click on Export, and you can see that this provides us with an option to export the current work plan to an Excel-compatible file, which could then be filtered by discipline and simply emailed to the design team or given out at the next team meeting. Over the next 10 days or so, the design team will be progressing those items in their individual focus periods, with the intention that they return to the next team meeting with all of their progress marked up. This is where the project manager can update the work plan by clicking on the View Edit Work Plan tab and entering the percentage completes that the design team are reporting. Obviously, in an ideal world, we'd like all of the red triangles, that is, those activities that should be completed in this focus period, to be reported as 100% complete, but in the real world this isn't always the case. Where a required activity hasn't been completed, it's very important to capture the reasons, and we do that by clicking on the Add Reasons for Failure button. Over a series of work plans, this function allows us to see if there are any repetitive delays that are occurring, and if we can take any steps to prevent them. Additionally, we're asked if we have any plan of action to resolve the delay, maybe by adding more resources or coming to an agreed assumption or decision on the output of an activity. You'll also notice that while activities are marked as 100% are ticked off, any activities that have an outstanding percentage still remain on the work plan. They do have to be completed in the next focus period after all. As well as capturing percentage completes, we need to use this team meeting to look at those activities that have a circle next to them. That is, those that are due to start in the next 2 weeks. We go through these now as a team and decide if there are any reasons that will prevent the design team from starting those activities. If there are, we record them using the Add Constraints button, and we enter when we expect that constraint to no longer be a problem. In this case, I've said that we're waiting for some design information and it's going to be available a week later than we'd expected it. If I click OK here, you'll see that the icon next to the task changes to a hazard symbol. This indicates a delay on the program, and if we were to update the program now, all of the activities that depend on this one as an ultimate predecessor will be delayed by that 1 week. Now this might not be a problem, but if the delay is severe enough, it may be that we need to take some action to release this constraint. If I open up the constraint editor again, we do have the option to tick this Work at Risk box. That effectively breaks the constraint, but we have to have a logical reason for doing so. It may be that a design team can agree the information is delayed or come up with a strategy to mitigate the requirement for it, but there has to be some rationale for releasing an identified constraint. Otherwise, the program will automatically update with the delay. In addition to managing constraints, Design Manager allows us another opportunity to review the information dependencies that drive a project plan. If I select an activity and then click on Information Requirements, I can see not only the information needed and where it's coming from, but also the criticality of that piece of information, something that isn't provided in any existing planning tool. Knowing this criticality gives us an ability to edit the information required ahead of when the task is due to be done by clicking on the Edit button and selecting Do not wait for this information to become available. In effect, we're making a decision about that piece of information in order to remain on plan. In the same way that we did in Design Builder, we're reducing risk of unknown assumptions by justifying all of these tears. Having done that, you can see that the information required is now grayed out. Once we've been through this process, we click back on the Manage Work Plan tab and then on the Archive button. Again, the software's reminding us that we're working offline, and I'll accept that, but then it throws up an important window. This is a message to the project manager asking them to confirm that all of the activities that have been reported as 100% complete are really fully complete, with all of the required information available from them. As you can see, the software then updates our program with all of the new information, and we could reschedule it here and start the process all over again for the next 2 weeks, drafting a work plan, publishing it to the design team and awaiting reports. Only this time the activities that were on the last look-ahead period are in this work plan's focus period, and we're looking a further 2 weeks into the future for this work plan's look-ahead period. As progress on the second work plan is moving ahead, I'm going to take the opportunity to show another function of the ADePT software that differentiates it from conventional planning tools, and that's the ability to cope with iterative loops. I'm going to move back to the Primavera program that we've created our work plan from. You can see that I've sorted the program into a WBS view, and that by clicking on the Reschedule tool, we can see the scheduled plan. A design manager or planner may well need to make some changes to the program as it evolves throughout the project, and I've created a small section here called Loop Example to show specifically what we're doing. As this diagram shows, we have a series of 3 sequential activities, and I'm going to put in a dependency saying that activity 1 depends upon activity 3. When I do this in a conventional planning tool, as I'm doing now in Primavera, and then press Reschedule, the planning tool throws me an error saying I've created a circuit and suggests that I've made a mistake. This is an incorrect assumption, as design by its very nature is an iterative process. Conventionally, in order to resolve this circuit error, a planner would either miss out the dependency entirely to avoid the problem, or they'd falsify the sequence to promote linear steps that work around the fact that an iterative loop exists.